Hello and welcome to Donkermat channel. I would like to address today a question which I think I have the answer, but I'm just not quite 100% certain. So I have a pen and a piece of paper. I want to speak about convexing and to something, for example, some time back I was listening to William Collins, maker William Collins, whom I respect and admire greatly, speaking about how he doesn't like to convex an edge because you're steepening your cutting bevel. You're steepening your apex when you convex. Because if he makes a knife, let's say he does a saber grind, so you got your flats, and then you got your secondary bevel, which some people call the primary bevel, right? And then you're putting in your primary bevels here, right? So this V, there's your primary bevels there, right? And he does these very steep, so this is like 17 degrees and whatever, but so you get the point. So now we're convexing, right? Coming in here and we're convexing, we're making this steeper, right? And so this is what I call convexing in. I don't think this is scientific terminology, and I don't know if anyone else says it like this, but it just seems to me logical. Here you're convexing in, right? Now, if I take this same thing, try and replicate that, okay, and then I don't touch here, I come in here, right? So here I cut there, right? Now I make a new facet, right? So now I have a shape like this. Now I have primary, secondary, and tertiary bevels, correct? And so now I cut there, and I cut there, right? But I don't touch this, right? That is what I'm calling convexing out. And so I've just heard it asserted as fact, as physics, right? That when you convex an edge, you are therefore steepening your cutting apex, right? There's no way around it. You're thickening up here, right? As opposed to a V edge. And so what I'm saying is no, because I can take this V edge and I can cut it back in this direction, right? And convex, and certainly I sharpen freehand, so there's no way that I could not do this convex. Because that's the interaction of physics with reality, which is that you can't make a flat plane on a flat plane. So I just thought that, for me to work it out, I didn't sketch this out on paper this morning when I was thinking about this. Well, I was sat on the toilet and then I went and grabbed a wooden sword, right? So this black line there, okay, I think that's because I charred it, right? Because I was trying to harden the edge, okay? And this is all kind of convexed anyway, right? But let me try and make let me sharpen my knife first, right? And then we'll do the same thing, okay? So I'm going to cut myself a fresh little apex bevel, yeah? Because I tried scraping Cerakote with this last night, and it did not work very well. Okay. So now I've thickened, yes? Okay, so now what? Well, now let me grab this And this was 1,000 grit, by the way. And this is going to be maybe like I think this is a 300, something like that. So now I'm laying flat, right? I'm not on the apex. And in principle, I will say that this knife is a convex to 0, right? Hamaguri grind, full hamaguri. So there should not, in principle, be a flat line on this thing. Now, of course, if we were to look at this finer and finer, we could start to find concaves. How? Because there are scratches. Yeah. And that's going to be a concave scratched into the surface of this. But broadly speaking, what we have here is a full convex, okay? Now, so, yeah, now I put a flat on, right? Flat-ish, but it wasn't flat anyway. So forget about it. It's all convexed. Okay, and I stayed off the apex, right? So now, what's my apex angle? It's about there, right? So now I'm going to blend that all in. You understand? So imagine I just keep doing this, staying off the apex until this spine is half as thick. That will help you to visualize what's happened. Have I thickened out behind the actual where nothing turns into something of the blade? No, I have not. I have thinned it out only. Finally, yes, they were because of the nature of how you have to work the steel. I'll go through a thickening phase where I retract the apex. Okay, so that probably cuts now. Can you make a perfect circle? I'm not sure I actually got apex there. It's not very helpful to my demonstration. Okay, so V edge, right? Just going to do this little section here. And in fact, how do I make a flat V edge? I make a hollow, see? I'm going to use this belly. And see how I'm actually creating a hollow here. I can feel it. Now, I flatten that out. How do I flatten it out? I can go in a little here, and I can go in a little here. Now, what am I doing? I've moved my shoulder. See that? I can keep moving this shoulder back, and it doesn't finish when that shoulder gets to here. Because I've still got all of this to work through until I reach that line. You understand? Convexing out. Okay. Now you see, you understand. I could keep working here I can keep removing right until the line. Okay. And so now, since broadly speaking, this side was symmetrical with this side, and this side is convexed, and this side is also convexed, therefore, I rest my case. We are thinner. If I replicate this on this side, now I have convexed out. My edge has not steepened, the cutting apex has not steepened, and please consider that I can continue to convex here, right until I reach that line and not go past it. And then I can back it up and I can make this cutting edge steeper. I mean, shallower. Yeah, shallower. I always get those mixed up. Steeper and shallower. Even shallower. Okay? Until there's nothing left. Thank you for watching.